Thank you everybody for joining us. Today we're excited to have you with us. A special warm welcome to our guest speaker, JC du Preez. We're looking forward to hear your insights from our past experiences, which you'll be sharing shortly. Welcome, JC. Myself and JC will be presenting today. So I'm Christa Dowd from Foresight OT Automation, leading the digital energy team. And with me, I've got JC du Preez, heading up the digital and automation operations at Tharisa Minerals. So in today's session, we'll cover an overview or introduction about Tharisa Minerals. JC will tell us a bit about the problem that they had on site, and I will go through the solution that we implemented. We'll also have opportunity for you to add comments and questions to the comments section. Please note that we'll answer the questions afterwards via email, so that allows us to give the right attention to your inquiries. So today, covering the sustainability solution that we implemented at Tharisa Minerals, I'm handing over to you, JC, to tell us more about Tharisa.
Thanks, Christa, and welcome everyone to watching live and also the recording afterwards. It's a great opportunity to share our story. Okay, you can go to the next slide. I'm going to share with you a little bit about Tharisa Minerals. Let me just go there myself. Okay, there you go. So, Tharisa Minerals, I think this is the one. Okay, so we see ourselves as an innovating company that is innovating the resource company of the future. What that means is we get ourselves ready for the employee of the future, and we found ourselves in quite a broad stream in these commodities from exploration that we in-source mining. We've got open cast and underground mining operation, processing where we process up to smelting, refining that product, and then also the market, the sales and logistics. And we mainly focus in precious metals, chrome alloys, and energy storage, quite exciting, and base metals for the market. Okay, that makes us quite diversified. To show you Tharisa's footprint, Tharisa Mine is right here in the northwest province of South Africa. That's where I'm based currently, and we see ourselves, or we are a shallow multi-generational mineral assets that we mine. So meaning that, after myself, maybe beyond my retirement, the mines that we are developing and putting in operations will still be there for our future generations to come. So that's quite exciting that that whatever you do today has an impact going forward. You can see there on the presentation in Dortmund in Germany, we've got Redox One, and that's an exciting product. It's an iron chromium redox flow battery that we've developed that you can go and do some research on. Then Tharisa Mine. What's interesting about Tharisa Mine is the biggest open cast mine in the southern hemisphere that mines 2 commodities. So that makes us unique. The next one is Karo Platinum in Zimbabwe. That's on the Great Zimbabwe Dike. That's about 500 kilometers reaching from the south to the north. That's the dike. So we are right on that. And this dike includes all deposits from gold, silver, chrome, platinum, nickel, and even asbestos, if that's something that you're into. The next one is our Arco Metals Renewable Energy Center. That's our research center. Also here with great South African scientists that are developing there and doing research fast to make sure we contribute to the circular economy. We've got our Arco Metals beneficiation site where we take the chrome that we mine and we benefit it, and that feeds back into our Redox One solution, and then obviously logistics to make sure that we can transport and do distribution. Yeah, that's our footprint as Tharisa, and so we're not just a mining house, but we are actually an asset business. Okay, so for today, with our topic regarding decarbonisation, we've got critical metal applications, and the first one I'm sharing today is because I mentioned that Tharisa Minerals are mining two commodities. That's PGMs. That's the chrome, PGMs, the platinum group metals, and also chrome. But so the first one that's quite applicable in decarbonisation in the planet is PGMs, because you can see on the left where we've got growth opportunities in the sectors across, from electric vehicles, CO2 batteries, hydrogen decarbonisation, catalytic converters, aeroplane engines, data centers, fertilizers. So it's being utilized quite broadly in the market. So it's a commodity that's used. Now I've made some notes that was interesting for me to share with you guys. And we know that since the stable internal combustion engine demand, we know that PGMs will still be there and be mined. The market value currently is sitting about at 114 million US dollars, and it will grow billion, and it will grow to 129 billion by 2023. That's a compound annual growth rate of about 1.5%. So the PGMs market is stable, and hence we need to focus on how do we partake and participate in this market on a respectful way. The next one is the hydrogen economy that's quite growing, and that will provide a multi-decade PGM demand. So PGMs will stay relevant, and the major energy carrier, example fuel cells in vehicles. The one I've mentioned is green hydrogen production via electrolysis using renewable energies, and PGMs assist and aids in the decarbonisation goal. Okay, so that's the second critical metal application is our chrome, that plays a vital role in decarbonising the planet. And you can again see there's a broad spectrum of applications for chrome, and then the future growth ones is the one on the left, where chrome is quite 100% recyclable. It assists with pollution control systems in industrial scrubbers and filtration, electrolysis and storage systems like for green hydrogen, renewable energy technologies like solar, wind, stainless steel, desalination of water, purification of water systems. Yeah, so chrome is quite broadly used. So interesting facts about chrome is there's no substitution for chrome in stainless steel production. So we're going to need to be aware of that. It's safe, cost-effective, reliable, sustainable, and scalable. And close to home to us for our Redox 1 iron chromium redox flow battery are poised to power a decarbonised future in a market growing to, we estimate, about $3 trillion US by 2040. So that's a cool space to be in. And then according to the International Energy Association, by 2030, the world is projected to grow intermittent renewable by 3 times, reaching nearly 50% of the electricity generation capacity. So there's a demand. There's a demand for electricity, and the capacity is going to grow quite significantly. And that adds to additional 1.8 megaton per annum of chrome concentrates is required to sustain this 3.5% compound annual growth rate in stainless steel. So, yeah. Interesting facts, Christa, that you probably did not know before. Okay. Right, closer to for today's session on the award that we received for our innovative approach is that we focused, just for some background first, is Tharisa Minerals in positive environmental impact is that we plan to reduce our carbon footprint by 30%. With 30% by 2030. We aim to be carbon neutral by 2050. We've already started with a 40 megawatt solar plant in the Environmental Authorization Award. We have been awarded to do it. And we started with our first phase of 30 megawatt solar plant in Zimbabwe. Okay, so yeah, the I in Tharisa stands for innovation. And our digital energy platform that we're going to speak about today gave us an operational insights that have significantly reduced our carbon emissions. And our innovative approach is delivering measurable value with approximately 2,000 kilograms of CO2 emissions saved for each hour of reduced generator runtime. So in the next couple of slides, you will see how we got to that. Okay, great. I trust everything is fine. Okay, our problem statement, and how did we start off? I mean, I'm an engineer. My focus is solving problems, and initially there was no idea to say, okay, let's go and find a decarbonisation project. It was actually just this. So what it means is when you actually just solve problems, you can indirectly, like in this case, contribute to decarbonisation and have a positive effect by just applying, basic principles and following it through. So what caused our problem? What was our statement is Eskom had a big time where we had to do, or we still have load curtailment. And the load curtailment is different from load shedding, where the normal households has got load shedding and load shedding schedules. At the mine, we've got a load curtailment offer. So it means that we have a generator yard. We've got about 6 generators that can generate 6 megawatt of power. So we, instead of pulling, let's say, 40 megawatts from the grid, we just reduce it with 6 megawatt, and then we are pulling, the difference between that. So what Eskom would typically do is they send us an SMS, because that's the best way to say, Tharisa Minerals, please, you're on stage 4, load curtailment. That means you need to reduce your load pool with 4 megawatt, and you must do it from 2 o'clock up until 10 o'clock. And on this image, you can see the generator yard of the Voyager plant and the big stockpile in the right at the top. And then to the right is the electrical workshop, or the workshop where the artisans are sitting. And 2 o'clock is about 30 minutes before time to knock off and go home. So what typically happens is that they're busy with some work. 2 o'clock is when you do your paperwork, and then you forget that you've got this SMS to go and start the generators. 2:30, you run for the gate, and you're going to go like a horse in the stable. You want to get home. At 6 o'clock, when the next shift comes on, they communicate, they look at the handover notes, they realize, oh, we were supposed to switch on the generators. So the night shift artisan goes and switch it on at 6 o'clock. And then he's supposed to switch it off at 10 o'clock at night, but same habit prevails, and it just runs to the next morning, 6 o'clock. And then the day shift also comes in and he goes and switches off the generator. So we actually ran 4 megawatt for about 12 hours, from 6 p.m. to 6 a.m. instead of running it from, only for about, 8 hours or 10 hours from 2 o'clock till 10 o'clock. Now that's a double whammy in this case, because Eskom will penalize us because we did not stick to the schedule. We did not start at 2 o'clock, we're only at 6 o'clock, so that's 4 hours non-compliance. And then we also pay for that additional from 10 o'clock at night up until 6 o'clock, additional 8 hours of running time outside of the schedule, burning a lot of diesel, without anyone benefiting from us. Eskom, they don't mind because, we're giving them free energy, but we lose. So we got a double whammy. So I reached out to Foresight and I said, please help me with this human error. Let's enable the system to make sure that we can start the generators once we receive the SMS at 2 o'clock. And then at 10 o'clock, we can stop the generators automatically without any human interference. But there was a little catch on this because this is a legal operational site. We've got legal implications. We've got, there must be inspections done. You must ensure that the generators actually are in operational condition, and you have to follow the Mine Health and Safety Act requirements. So it was not just a straightforward solution. And then Christa can then take us through these processes next.
Great, thank you, JC. You certainly mention some statistics that I haven't memorized them or taken them to my notebook, but Tharisa is an interesting research environment as well as an operational environment, like you mentioned, with the eye for innovation. So just to give the highlight is that we actually won an award for the project that we implemented, which I'll tell you about shortly. And it's quite an honor to be noticed by Schneider Electric, as they have been nominated noted as the world's most sustainable company by Times Magazine in partnership with Statista. So globally, they've been awarded this status, and to be recognized by them as a local entity in South Africa is still quite an honor. So what we actually did at Tharisa was to look at what we can do to automate the entire process. And first of all, we needed the control parameters, which would be the stop and start time of the instruction that we got from Eskom. So that was encapsulated within the SMS instruction, but there's also a percentage of reduction that's expected. So if it's stage 1 and 2 load shedding, for example, or load curtailment, you need to drop by 10%, 20%. So those parameters were all derived from reading the SMS instruction. That instruction is then added to an algorithm that determines the priority of the generators that we want to start up. So we would look at historical parameters from the generators, the time to service, the running hours, look at how we can best optimize the generators in use. And of course, we'd rather use a generator running at a higher load and more efficient than starting up multiple generators at a lower load. So all of that happens within the control algorithm. And one of the critical inputs that JC alluded to is the requirement that these generators still should be physically inspected. So the operators would, on a scheduled basis, the operator or the technician would, on a scheduled basis, inspect the different generators, go through the maintenance requirements, and mark the generators as either being available for automated switching or out of the schedule. So on the diagram, you can see that the process flow then from the SMS instruction through to the algorithm, then automatically stopping and starting the generators to comply with the Eskom load curtailment instructions. The physical world. So what we did at Tharisa is on their medium voltage network, we installed the 3 meters on their Eskom intake points on the 11 kV bus. Then we've also installed the 2 generator feeders in that same substation to get a view of the actual takeoff from the Eskom grid and what is supplemented by the generators. We integrated to the 6 individual generator controllers, and this allowed us to create a rich real-time visualization of not only the control schedule, but also the parameters of each individual generator. So previously, they didn't have any way to remotely stop and start the generators. So now we've added that functionality for the remote stop and start, and we've also added the automation of the schedule. So just as an additional highlight, the meters that we installed is actually world-class meters from Schneider Electric. They're class 0.2S accuracy. So that is in line with your requirements from the utility side and our national standards. And they're also a class S power quality device, which allows you to have event notification and detection of SAG as well, or network voltage dips in your network. So that added a lot more visibility to Tharisa, which they did previously not have any access to. So the outcomes of this project was not only to have a compliant response to the Eskom load curtailment instruction. So there's an example on the right-hand side where they now have optimized the shift or the generation on-premise to comply to Eskom's takeoff requirements. And we've also added visibility of their actual consumption which was previously missing. We improved the load curtailment control by knowing what the actual base load is. So the way Eskom evaluates it, you have a scaled base load. So you provide them with some historic data. They calculate your base load, and based on your actual consumption on that day, that base load is either scaled up or down. That will allow you to start less generators or ramp down a generator if you can still be compliant up to 80% of your performance within that permissible period. We also now have a lot richer data set to provide reporting on. And of course, as I mentioned, these power quality devices have power quality capabilities as well to provide that insight previously not visible. One added benefit of these meters is they've got sliding window demand modules, which allow you to do maximum demand prediction. And if you're looking at cost reduction within an operation this size, it's a significant cost not only to look at your power factor for reactive energy, but also at your maximum demand contribution. So you're penalized over a 12-month period for your maximum demand, and now you can have an upfront warning if you will be exceeding this maximum demand within the 30-minute time frame that Eskom is looking at. So through the implementation of the automated control of these generators, we are saving, like JC had mentioned, 2,000 kilograms of CO2 emissions per hour of runtime reduced. So at 10 at night, it's switching off and there's no shift changeover problems because it's all running from the digital environment. Looking at data and energy in general, I think it's critical that operations include energy data and the related data sets in their overall data strategy. We come across so many instances where there's quite a big gap between our OT environments and our IT environments, and how that facilitates the operational needs of the facility or operation. So just keeping that in mind, I think if we are driving sustainability objectives, which is typically quite, I can't think of the word now, but lofty goals that we set ourselves. It's important that we have the structures in place. So we want to have visibility of whatever we need to control. We need to be able to control it smartly and drive these sustainability objectives. And just out of a point of interest, if we look at the Eskom annual report from last year, they're using 1.4 liters of water per kilowatt hour produced, and that's equivalent emission on CO2 is about 1 kilogram per kilowatt hour. So if we multiply that by our own household or operation like Tharisa or our national consumption, those numbers become significant. So creating visibility and managing that effectively becomes more and more urgent, actually, if you look at the dire consequences of not doing so. Just looking at the roadmap as well. So now on a site, we've got high level of visibility that we've already created. And through modern technology, we're actually now easily able to create awareness on a global scale. So let's take Tharisa an example where they've got distributed operations within different countries. We can create dashboards with real-time and historic data where we might not have the skill set at each operation to manage the entire scope that we're looking at, but on a global scale or on a aggregated scale, we can look at individual operations and have a shared resource pool to look at that. So what I've got on the screen here is the high resolution on-premise data. So there we can have real-time visibility and trending of voltages and currents and your maximum demand prediction. Those same data sets, of course, I'm talking about a curated data set because I don't think it's feasible to take all your data into a cloud environment because you're overloading your consumption, you're paying unnecessary fees, and it's also, if it's not utilized, what is it doing there? If you've got that curated data set, now we can look at critical alarms on your site that you want to notify the individual operations of, or that you can push into a workflow and take the necessary actions of that on a global level with the skills then as required.
Yeah, if just go back, Christa, if you can, before we go to
Yeah.
thank you, because I know two sides. Yeah, go one more. So part of the roadmap, if you look at this with this step-proof, the words has been the biggest word that's popping out is security, energy security, digitalization, IIoT, and data analytics. I mean, these are all relevant words that's standing out, and that talks to your point where you spoke about the overloading the data. So if you go to the roadmap slide, and if to these points, then let's go to the next one. So on our roadmap, to make sure we've got a curtailed centralized insight, is to ensure that you actually build your IoT architecture correctly to enable this. So what we did is we installed the correct hardware on site on the OT network with the correct protocols activated, to enable us to go to the next phase, so that we can actually sit at a head office level and look at our Zimbabwe operations and our South African operations from one single pane. So that's also what these hardware that we got from Schneider Electrical gave us, is to make sure that we can actually go that route and follow these architectures that's made available. And it's been coming a long way, but the market is quite ready for this step. I'm looking forward to say, okay, in a year's time, or in the next term, when we can maybe have a follow-up session of this webinar, and we can show you our landscape and how we've developed it, and to make it a reality from just a talk point to a reality. And the same with this decarbonisation, that we did say, okay, how do we practically implement, apply this? And this is what we've done. Okay, cool. Thanks, Christa.
No, thanks, JC. We always talk about the art of the possible at Foresight, and what we've showed you, it's a simple solution, and there's the building blocks of so much more enabled through what we've already done. So thank you for your time, JC. Thank you to everybody attending. You can still leave some comments. We can get back to that afterwards, and thank you for your time.
Yeah, nice within 30 minutes. Thanks all.
Thank you.